Good day, everyone. The lesson or topic that we will tackle for today is all about gas laws. First, let me ask you a question. What is gas laws? These are laws that are related to the pressure, volume, and temperature of a gas. It tackles about the findings related to the three mediums or variables, which are the pressure, the volume or amount, the temperature when coming to matters of gas. The gas laws consist of primary laws. These are Charles' law, Gay-Lussac law, Boyle's law, and Avogadro's law. And then, let me give you a hint what is three laws all about, or these primary laws all about. First, the Charles law. It tells us that the volume of the gas increases as the temperature increases. Boyle's law. It tells us that the volume of gas increases as the amount of gas decreases. Third one is the Avogadro's law. It tells us that the volume of gas increases as the amount of gas increases. And lastly, the Gay-Lussac's law. It is when the pressure of a given mass varies directly with the absolute temperature of gas when the volume is constant. What is ideal gas law? It's a combination of the three simple gas laws. Ideal gases, or what we call the perfect gas, is the theoretical substance that helps establish the relationship of four gas variables, which are the pressure, volume, amount of gas, and temperature. So, kaning ideal gases kay it consists of the four gas variable if wala ang usaan ni nila bisag ang for example ang pressure kay dili na siya matawag og ideal gases or perfect gas. Ideal gas is defined as one in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular attractive forces. In such a gas, all the internal energy is in the form of kinetic energy, and any change in internal energy is accompanied by a change in temperature. It is a concept which is useful because it obeys the ideal gas law, a simplified equation of state, and is amenable to analysis under. And the term ideal gas refers to a hypothetical gas composed of molecules which follow a few rules. Ideal gas molecules do not attract or repel each other. The only attraction between ideal gas molecules would be an elastic collision upon impact with each other or an elastic collision with the walls of the container. A gas having particles that have perfectly elastic collisions and negligible volume and intermolecular forces, thus exactly obeying the ideal gas law. No known gas is an ideal gas, but actual gases approximate this behavior at relatively low pressure and high temperature. The ideal gas has its characters described as follows. First, the particles in the gas are extremely small, so the the gas does not occupy any spaces. Second, the ideal gas has constant, random, and straight line motion. And the third or the last one is no forces between the particles of the gas. Particles only collide elastically with each other and with the walls of container. So, the next gas is the real gases. The real gases. Real gases, in contrast, has real volume and the collision of the particles is not elastic because there are attractive forces between particles. As a result, the volume of real gas is much larger than of the ideal gas, and the pressure of real gas is lower than of ideal gas behavior at low pressure and relatively high temperature. A real gas is a gas that does not behave as an ideal gas due to interactions between gas molecules. A real gas is also known as non-ideal gas because the behavior of a real gas is only approximated by the ideal gas law. Real gases have attractive and repelling forces, non-negligible excluded volume, and lost energy when colliding with other gas particles. So, what is an example of a real gas? Any gas that exists is a real gas. Nitrogen, oxygen, carbon dioxide, carbon monoxide, helium, and etc. Real gases have small attractive and repulsive forces between particles and ideal gases do not. Real gas particles have a volume and ideal gas particles do not. So, what are the difference between ideal gases and real gases? An ideal gas is one that follows the gas laws to all conditions of temperature and pressure. To do so, the gas would need to completely abide by the kinetic molecular theory. A real gas is a gas that does not behave according to the assumptions of the kinetic molecular theory. So, let's talk about the primary laws that are related to gas laws. First is the Charles law. Jacques Charles, a French physicist in 1787 who discovered the correlation between temperature and volume, assuming pressure and amount of gas remain constant. So, what is Charles' law? It is an experimental gas law that describes how gases tend to expand when heated. So the formula is here, posted on the PowerPoint. V1 is V1 over T1 is equals to V2 over T2, where V1 is the first volume, V2 is the second volume, T1 is the first temperature, T2 is the second temperature. So, here are the Charles law examples that we can see everywhere and bisag na sa atong body. So, the tires, lungs, ping pong ball, helium balloon, bread, hot air balloon, floats, and etc. There are so many examples jud about sa Charles law nga atong makita sa atong palibot. So these are the examples or the Charles Law examples. So another a real life examples of Charles Law. Tires of untouched vehicles get deflated during freezing winter days while get inflated in hot summer days. This unusual behavior is because of Charles' law. In winter, due to low temperatures, the air inside a tire gets cooler and they shrink, while in hot days, the air expands with temperature. So the next one is the Gay-Lussac's law. States that the pressure of a given mass of a gas varies directly with the absolute temperature of the gas when the volume is kept constant. Temperature also illustrates a direct relationship. As a gas is cooled at constant volume, its pressure continually decreases until the gas condenses to a liquid. So, here is the formula of the Gay-Lussac's law. So, it states or it shows that it is P1 over T1 is equals to P sub 2 over T sub 2. Where P is the pressure exerted by the gas, T is the absolute temperature of the gas, and the answer where it is a K, it is a constant. So, these are the real-life examples of Gay-Lussac's law. The pressure cooker, the tire, aerosol can, and the heater. First is let me explain about what unsay nakarelate aning pressure cooker sa Gay-Lussac's law. When the cooker is heated, the pressure exerted by the steam inside the container increases. The high temperature and pressure inside the container cause the food to cook faster. So if kanang kusog imong kalayo kay kanang maluto jud imong kuan, it's because of the temperature or the high temperature and the pressure inside nga naa sa imong rice cooker. So the next one is kaning aerosol can and a tire. All these substances explode when exposed to higher temperature. For example, ang tire kay kanaw kung palabian, kung pakusog kag taman, or another example lang kanang imong palabian og bomba imong ligid. So nay possible nga tungod sa pressure sa sulod sa tire kay makuan siya kanang nay possibility nga mabuslot, mabuto, ingana siya. So that's the kanang example, real life examples of Gay-Lussac's law where kanang makita ra nato sa atong palibot. So, Gay-Lussac's law is a gas law which states that the pressure exerted by a gas of a given mass and kept at a constant volume varies directly with the absolute temperature of gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. Examples of Gay-Lussac's law kaning aerosol can, such as deodorant can or a spray paint can. It is when heated, the resulting increase in the pressure exerted by the gas on the container owing to the Gay-Lussac's law, so related to gapon sa Gay-Lussac's law, can result in an explosion, of course. This is the reason why many pressurized containers have warning labels stating that the container must be kept away from fire and stored in a cool environment. For example, kanang mga tangke sa kanang kuan sa stove ba, nya kanang kung palabian nimo siya kung imo siyang ibutang sa heat na possibility nga mag-cause og dakong nga sunog. Mao ra gyapon na siya sa tire, sa heater, and the pressure cooker. And so that is all my part as a reporter, and Joy Eileen will continue our report. Joy, you may proceed now.